Syzygy, episode 15, Salty Lake under the South Pole of Mars. Seems likely. And welcome back for another episode of Syzygy. By gee, it's a busy week. If you tuned into episode 14 last week, then we were talking all about the eclipse, but that hadn't happened yet. So before we get into anything else, we're going to be talking Mars and a bunch of stuff that's been happening on Mars. But before we get to that, Emily Brunsden from the University of York, it's been a big couple of days.
Well, indeed. It's probably been some of the biggest days of my entire life.
Emily's sitting opposite me here at the desk in her office, and she's got a little bit of a look in her eye, which is, I haven't slept in like 72 hours. So we did the recording for this podcast sort of early to mid last week. So it was a few days before the big lunar eclipse. And for those of you who've been living literally under a rock, there was the longest lunar eclipse for this entire 21st century last Friday night UK time. And we were all set for moonrise in full eclipse. It was going to come up. It was going to be blood red, a blood moon, a micro blood moon, as it turns out. But you can listen to last week's episode to get all of the details about that. Very, very exciting. And then the media office here at the University of York, doing their job fantastically, said, well, we've got an expert here. We've got Emily Brunsden, Dr. Emily Brunsden. She's an astronomer. We should tell people that she can talk about this stuff. And your phone started ringing fairly early on Friday morning.
6 o'clock Friday morning, I started getting the emails in saying, we'd be quite interested to have you on our little show.
And it didn't stop all day. So who did you speak to?
I was very, very lucky, actually. So the press office put out a few comments, and that was picked up by lots of different outlets. So, first and foremost, I have to say that I did talk to Minster FM here in York.
Okay,
good old guys.
Let's start local and move our way out. And good old Minster FM.
Yeah.
I mean, they, forgotten in the grand scheme of media organisations of the world, but, they're all right.
Yeah, so about 6 o'clock on Friday morning, I got an email asking if I'd come on the Victoria Derbyshire show on BBC Two. By that evening, I'd had emails from BBC News, BBC World News, and Sky News, as well as BBC Radio 5.
So this is not just local here in York. This is nationwide. This is worldwide. What's the furthest flung that your media about the eclipse went?
Well, I definitely made it to New Zealand on BBC World News because lots of my friends and family were listening out for that one. So that was really cool.
So that's literally the other side of the world. If you draw a line through the center of the Earth from where we are now, it comes out into the southern Pacific, sort of Antarctic Ocean, a couple of 100 k's off the coast of New Zealand. So, you literally made it to the other side of the world. So well done. The punchline... So how was the viewing of the eclipse here in York on Friday night, Emily?
It was an absolute washout.
Literally a washout. For those of you who don't know, most of the United Kingdom seemed to be covered by ridiculous lightning storms on Friday night. Like the huge heat wave that we've had broke on Friday, and it broke in a big way.
I haven't yet seen a picture from the lunar eclipse that was taken in the UK.
No.
I'm sure there might be one or two out there.
I had friends in Australia, in Sydney, who were sending me pictures where they had to get up really bright and early in the morning to watch it, but they got great pictures of the eclipse, and I'm just pouting, going, that's just not fair. You guys weren't even supposed to have it. This one's ours.
Yeah.
No, nothing. Absolutely nothing. So the entire country was closed down by thunder and lightning. We didn't get to see the eclipse, but that's okay. I got a message from Emily fairly late on Friday night saying, hey, that's astronomy.
Yep.
What are you going to do?
Exactly. We've become professional cloud watchers as astronomers.
The nice thing is there is no shortage of photographs and videos and animated GIFs of the longest lunar eclipse of the 21st century online. So if you really want to see it, if you didn't manage to get out there and see it, you can just get online and Google it, and you will find, to your heart's content, this amazing phenomenon. It was pretty cool.
It was very cool. And there will be other lunar eclipses. So, keep tuned to Syzygy because we'll definitely talk about the upcoming ones as they come as well.
Definitely. And, Emily's just going to go and have a week-long nap now. Oh, dear. So on to the main topic for today. We're talking about Mars. Now, we've talked a bit about Mars over the last couple of podcasts because there's just been a lot of stuff going down. It's sort of come incidentally into some of our conversations and directly into some of our conversations. But we've got a bit of news that we need to talk about. Again, maybe you've been living under a rock for the past week, but there's been a lot in the news about a discovery on Mars. But first of all, how's the storm going?
Wow, it's
Speaking
still
of
raging.
storms,
Yeah. So Mars is that other red thing up in the sky.
That's right, yeah.
So if you missed out on the blood moon, the lunar eclipse, then good news is that over the next few nights, actually for a couple of weeks, you'll still be able to see Mars at nearly its absolute brightest that it can be in our sky, which is pretty cool.
And that means, if it's at its absolute brightest, presumably that means that we're seeing a full Mars in the same way that we would see a full moon. In other words, Mars is Sun, Earth, Mars. We're in a syzygy, aren't we?
We're in a syzygy.
Woohoo! Tick another one off. There's another syzygy. Fantastic. So, whereabouts in the sky do we look to find Mars?
Actually, it's not too far away from where the moon is at the moment in the early evening here in the UK. It just depends on where you are in the world. In the evenings or at the time of the eclipse, then you would have seen it at slightly different orientations, but it's just coming up over the southeast horizon for us here at sunset.
Most excellent. So it's bright, it's visible, it's prominent in the sky, and there's stuff going down on Mars. There's a big storm. We reported on this the other week. Started a number of weeks ago, and the thing about storms on Mars, it's a very stormy place. I think I'm right in saying that because the atmosphere is actually very, very tenuous. There's not a lot of atmosphere on Mars. It does tend to mean that things like dust storms tend to build up and get really, really big. And in this case, covering the entire
planet in one dust storm.
Which is the sort of thing that you sort of expect in science fiction. But this is real.
So cool.
And it's sort of kind of personal for us here on Earth because we've got some things up there. We've got the rovers, which have gone into full shutdown, batten the hatches mode. Because, A, they're made of electronics, and so dust's not such a good thing. But B, they're solar powered. So they're kind of, when there's a really big dust storm going on, they sort of got to just shut up shop and hope that everything switches back on again when the storm's died down.
Yeah, so Opportunity particularly, which is the rover that used to have a twin called Spirit, but it's definitely the plucky little rover that could.
It's been going for how many years?
Many, many, many years
early
now.
2000s?
Yeah, early 2000s.
Goodness me.
I have to check the date. But yeah, it's amazing. That's the sort of the slightly more risky one because that good old Opportunity has solar panels. So if you coat the solar panels in dust, then they're not going to work very well. So Opportunity is definitely in sleep mode at the moment. Curiosity, if you'll be pleased to know, should be pretty much fine because it's got an onboard power source.
And Curiosity is one of the later rovers, isn't it?
Yeah,
it was about
2012.
10 years? No, not even about 6 or 7 years ago. And it's been doing its thing. They're all sort of going well and truly above spec at this point. But you said it's got an internal power source. It's not totally reliant on solar.
No.
So it should be okay.
Yeah.
Provided it can sort of get through these pretty nasty storms.
This is Curiosity's first big dust storm.
Oh, so this is trial by fire.
Yeah. So the last one was in 2007. But you'll be pleased to know that everyone is very, very excited because this is exactly the type of thing that we can use to learn more about Mars as well.
Well, yeah, I guess in a strange way, you kind of hope that everything does go well. On the other hand, even if things do go badly, you're still learning a lot, right?
Yeah, and we've got so many orbiters and rovers and things going on Mars. We're going to know much, much more about this dust storm than any other ever we have in the past.
Yeah, and with plenty more missions coming up. The success of the missions so far have kind of spurred on a whole new generation of missions from NASA, but also from the ESA. Everyone's sending stuff to Mars in the next couple of years. And if you want to be a part of that, the competition's still open to name the ESA's ExoMars mission rover. So you can get on there and throw it any name you like, and a panel will choose the best name. So it's probably not going to be Rovery McRoverface.
Or Dusty McDustyface.
Or Dusty McDustface. But if you've got a better idea than that, then go and Google that. And given that the UK is still, as far as I know, part of the European Union, then we are still part of this Europe represented by the ESA. So go and give it your best shot, and you might get your name up there hoovering around on the surface of Mars in a couple of years' time.
And definitely go and check out Mars in the Sky, because this is the brightest it's going to be for 15 years. So it's worth a quick peek out in the next few nights. And again, it's not going to be a one night only thing. It was maximum on the 27th, but we've got another couple of weeks where it's still going to look pretty spectacular.
Yeah. So if the clouds are over tonight, you haven't missed anything, unlike the eclipse. But you haven't got forever. So get out there and check it out in the night sky.
How cool is that you can go and look at a planet in the night sky and actually see what colour it is without any special equipment, without any magical telescopes?
That is the very cool thing about Mars, isn't it? Is that you can look at it and go,
actually red.
That one's definitely Mars. Like Venus, you can tell because it's so bright, the morning star or the evening star, and it's always quite close to where the sun is coming up or going down. It's pretty easy to spot. That one's Venus. But the other ones, is that a star? Is it a planet? It seems pretty bright. But Mars, no doubt, and particularly when it's this bright. Is it bright? Is it red? It's probably Mars. Yeah, it's a good one. So what else is going on, though? Mars has been in the news, and it's not just because it's big and bright and red, and it's not just because there's a big dust storm. There's been a big announcement by, and again, it's the Europeans, isn't it? This is the European.
Yeah, so this is an Italian group that have been working at the INA in Bologna in Italy. And so this is Orse et al. And they put out a paper on the 25th of July, which is, maybe that's coincidence, just before Mars is
I don't know.
brightest in the sky. Maybe it's just luck. But they put out this finding that they have, which is that they've found for the very first time stable liquid water on Mars.
Now there is a little bit of an asterisk on that, isn't there? And we might come back to that a bit later on. But they have found, like all of the articles and so on. I've read through the paper online. It's all very sort of positive. Yep, we're pretty sure it's there. But there is still a little bit of an asterisk, which is, well, based on the evidence we've got, it seems to be something that looks quite a lot like an underground saltwater lake.
Yeah, this is the best possible match we have for the data.
Yeah, there are a number of people sort of, associated with or peripheral to the study who are going, well, it's a bit hard to tell. So I wouldn't necessarily say it's absolute, like go down and put your foot in the lake and go, yep, it's nice and warm, let's go for a dip. But it's the best evidence we've ever had for actual liquid water actually on Mars, actually now.
And that's very common when we talk about discoveries in our solar system, actually. We have very limited techniques that we can use on other planets other than our own. So we always do have to be careful a little bit. But in some ways, it's no less certain than many of the other things that we have talked about already on the podcast.
Cool. So how did they find it then?
Well, actually, using quite an old-fashioned technique called radar.
Right. Okay. So sort of World War II stuff, sending electromagnetic waves down to the surface, bouncing off stuff and coming back and measuring time of flight.
Yeah.
Right? That's radar.
Yep.
So how do you detect water with that?
Well, so what they were doing were using 3 to 5 megahertz radar signals and looking at the interference of those signals as they came back to the spacecraft. So this is an orbiting spacecraft. It's Mars Express.
Right.
And they were sending down these radio waves, and then you get an instant reflection off the surface of Mars.
Okay, so that's basically saying there's Mars.
Yep.
Mars is there. Mars is still there. Yep.
Yep, and you can time that signal, and you can work out, therefore, how far high, if you like, your satellite is at the time.
Yeah, by measuring how long it took to go down, bounce off and come back.
Yep.
And there's not much in the way, and so you just do a quick time of flight, and there's the surface. Great.
Yep. And then you compare that to another signal, which is a slightly different frequency, and that goes down, and that will actually penetrate a little bit into the surface.
Okay, so the waves can actually get a little way in.
Yeah. So on the south pole of Mars, for example, then you've got this big ice cap. Well, it's kind of a mixture of ice and dust. And that the radar waves travel straight through the ice, but then they reach something else and they start bouncing back.
Right, and looking at the research paper online, it looks like, I mean, you said a second ago, it's sort of ice, it's got a bit of dust in it. There are actually layers of this stuff, that there's kind of layers of dirty ice, and then there's a layer of just dirt, and then there's a layer of ice again and stuff. And so you can see those layers as you go down. But when they looked at the data really carefully, they saw some characteristics in some of these layers. And it was a strip about 20 kilometers long, wasn't it?
Yeah.
Which is, pretty long. That's a big feature.
It is.
And interestingly, it was really flat and it was kind of parallel with the surface, which suggests, well, there's a structure down under there which is horizontal, which is flat, which is like a surface of a lake.
Yeah, well, so it's bouncing back these signals, and from looking at the power or the intensity of those signals, you can tell a little bit of something about what is reflecting those signals back at you. And they look at something called the dielectric constant, or the permittivity, basically how reflective is a material to these particular signals. And it was through comparisons to those to some measurements that we've made on Earth, specifically in Antarctica, actually. So we've managed to use radar to find underground lakes in Antarctica using this technique. And so they had something to compare to, which was quite nice. And therefore they could say, well, there's some liquid water, or at least liquid water is the best fit of a material that's reflecting back these radar signals.
Which is really cool. And as you said, we've used the same technique down in Antarctica to find liquid water way down under the ice, like really, really long way down. And there are teams of geoscientists who are at the moment trying to drill down into that lake. It's a little bit controversial, actually, because, this is one of the few untouched bodies of water left on the planet. And there's a lot of questions around whether or not putting a drill down to check it out. Might be all sorts of interesting stuff down in there, but you're also poking into that for the first time. So
yeah.
it's a bit of
How do you look
controversy.
at it without contaminating it? It's a really good question.
Exactly. And do you take that risk in order to make scientific advances? Anyway, so there's that. But using the same radar technique, they've been able to see this underneath the South Pole of Mars. Now, there's something worth touching on there. You might be forgiven for thinking that we've told this story before. Surely, hang on, didn't we discover water on Mars like ages ago? And haven't we been continually discovering water on Mars? It seems like about every 18 months for the last couple of decades. Like, what's going on?
Yes, I actually remember the very first discovery of water on Mars. I think I must have been an undergraduate student at university, and that was huge. And what that discovery was all about was actually not water in liquid form, was water in ice form.
Right. And as you said a minute ago, the South Pole, or around the South Pole region of Mars, there is an ice cap. So there's obviously water there, but in solid ice form. So that's not what we're talking about in this discovery.
No. And actually we found quite a lot of this ice on Mars in the polar caps, both the North and South Pole, and also sort of buried underneath the surface in lots of different places as well.
Yeah, Mars is a pretty cold place.
Yeah, it's very, very cold. And it has a lot of water. I think one of the coolest things I read was if you melted all the ice on Mars, then you'd have an ocean that was more than 30 meters deep over the whole surface.
Wow. Okay, so that is a lot of water.
It's a lot of water there.
For something that doesn't look like a particularly watery planet, but so hence the interest in the discovery. The other thing, which of course makes the headlines with the words Mars and water in it, is the evidence for large quantities of liquid water in the past. That there's a lot of evidence on the surface features of Mars, the way water would form geological features, deep gullies and all sorts of things all over the surface of Mars. So it's clear that there was a lot of liquid stuff sloshing around a long time in the past, back when Mars had a much thicker atmosphere, was a lot warmer, had a lot more stuff going on geologically down under the surface, keeping it warm. But all of that's gone now.
Yeah,
and we're left
that's
with
really old stuff.
Like
right?
we're talking hundreds of millions, if not billions of years.
3.8 billion years ago is the estimate for when you would have had enough atmosphere to hold liquid water on the surface of Mars.
So, it's kind of staggering that we've still got so many obvious surface features 3.8 billion years later. Like, that's extraordinary. But there we are. But again, this is different. We found ice, but this is the first time that there is pretty compelling evidence that there is liquid water.
Yeah, and stable liquid water.
Yeah.
So it's not like, because Mars has seasons just like the Earth. So some of its ice caps melt, and so they do shrink during the Martian summer. So we know that there must be some liquid water that's at least transient on the surface. It probably evaporates off or gets frozen back down into the surface pretty quickly. But so technically it does exist for
Sure.
short periods of
Okay.
time. But no, this is the first time we found it. It's going to be stable because it's hidden underneath that surface so deep.
Yeah, this is a lake, not a puddle.
No.
You know, it's not gonna go away the next time the sun comes out. This is real. So that's cool. So interesting question out of all of this then is how? how do you get, like, it's really cold, right? As we've established, Mars is very, very cold enough to have a lot of ice. So how do you get liquid water? What is it? Is it about how far under the surface is it?
So this is 1.6 kilometers
Right.
down.
Which is a long way.
Long way down.
So how do you get a potentially 20-kilometer long lake under the ice in the South Pole region of Mars? How does that work?
Well, you know that the liquid water is going to be less than freezing. So we know that the surface of Mars is colder than freezing. So if you go down, there's nothing warm inside Mars. So it's not going to get any warmer down there.
Right. I mean, it's internal, the planet's internal heat systems, as we have here on Earth. You know, it's very hot down in the core of the Earth and in the mantle of the Earth. But that's not the case in Mars, is it? It's basically kind of burned itself out.
Mars is cooled off, yeah. It's small enough, it's got a bigger surface area, and it's lost all its internal heat.
Okay, so it's not geological heat, it's not geophysical heat that's warming up the ice and melting it and making this lake. So what is it?
Well, it's not actually warm at all.
Okay.
It's minus 68 degrees Celsius.
All right, now forgive me, it's been a while, but I'm pretty sure that water turns into ice at 0, Emily. So
It does, but only if you're at standard temperature
Right.
and pressure.
okay, so if you've got 1.5 kilometers of ice weighing down on you, that's a lot of pressure, and under those pressures, water could remain liquid at minus
Not all by
60?
itself. You need another factor. So pressure is definitely a big part of this, and we can see this in the underground lakes in Antarctica too. Pressure plays a huge role. But the other thing that can stop water from freezing is actually similar to the stuff that we put on our roads in the wintertime, and that's different types of salts.
Right. Hence the freezing temperature of the oceans being lower than 0, that you can have very, very, very cold temperatures and the salt water's still not freezing yet, for the same reason.
Yeah. So we, based on both the fact that this lake has to be this cold and the kind of properties of the reflected signal, then it's estimated that we have some magnesium in the water, some calcium, and some sodium.
Okay.
So that makes it really rather briny.
Yeah, not just salty. It's not sort of, oh, that tastes a bit like the Pacific. No, this is briny. This is very high
This
concentrations
is like
of salt.
sticky, salty
Yeah.
water. It's
Okay.
that thick with kind of these salts.
But with that amount of salt in it under those kind of pressures, it's plausible, completely plausible that you could have a liquid ocean.
And there's
liquid
really
lake.
not a good reason why you shouldn't on Mars, actually, because these are compounds that exist on the surface of Mars, so we expect them to exist deep down inside as well.
Sure. Okay. Why not? One of the lovely things I like about this story is that this 20-kilometer strip that they saw from the radar measurements with the orbiter. They could have seen this a long time ago. And in fact, they kind of did see it a long time ago. They sort of saw these blips in the radar, but ignored them because they didn't occur every time the orbiter went around. They'd sort of see it once and then the next pass over and the next one, they didn't see it. And so they just ignored it. And then eventually they kind of realized, oh, hang on, maybe it's got to do with the fact that in order to send all this data back down to Earth, we've programmed the orbiter, we programmed this satellite to compress the data. And so it was averaging over a number of pixels in its detector and sending those back. And so if that average kind of hit in the wrong way, then you wouldn't see the really highly reflective bit from the lake. So they had to send up this very quick software update, say, no, keep all the data for just this bit of your pass over the southern regions. And there it was, which is really cool.
Yeah, so the data come from 2012 to 2015. It's just taken us a while to sort of figure out what was going on. And you got to remember, I mean, this is an orbiter designed to look at the entire planet. It doesn't have huge resolution native to it anyway. So we got to, give it a lot of credit actually for being able to find this.
Yeah, and credit to the astronomers looking at it going, hang on a second, if we just tweak this program a bit, then we can see what we're looking for. So, as ever, with headlines which have Mars and water in them, one other word invariably comes up in or near that headline, which is life.
Yes.
So what does this say about, hey, there's water on Mars, therefore life? Does this add anything to that particular argument?
Well, of course, there are people who specialize in the kinds of extreme conditions that we find on other planets, and could life live there? If you want a very, very short answer, it's maybe.
which is the best kind of answer, because it leads to more funding.
Indeed. If you want sort of maybe a very, very honest answer, it's probably not.
Okay, right. But that still leaves the door open a touch. So.
Yeah, it does have a touch. So we know that, and we're not looking for, three-eyed aliens and things like that in this underground salty lake.
There aren't fish flapping about in the lake.
No.
As someone said on Twitter the other day, I don't think there are any mallards. I don't think there are any Martian mallards just, flapping about.
Wouldn't it be nice to have a lake without any duck poo, though?
Well, yeah. Anyway, so there aren't Martian ducks.
But there might be microbes.
Okay.
Now, the microbes need two things. They need an energy source, and they need some nutrients.
Mm-hmm.
Maybe those things exist. We're not really quite sure, because we don't even know how deep this lake is.
Yeah, I mean, I think reading from the paper, it said it's more than... It's like centimeters.
Yeah, maybe a meter or
but
two.
That leaves a lot of room for guessing.
More than that.
Yeah.
That's quite a big error bar.
Yeah.
But that's just the way the radar works. It's reflecting off the interface between the ice and the water, so you can't tell anymore.
So you can see the top surface. You're just not sure where the bottom is.
Exactly.
But it's at least in the order of centimeters, maybe meters. But then again, microbes are very small. They don't need a lot of room. But as you say, they do need food and energy. So
they'd have to find a way to extract food/energy from their environment around them. Not so impossible. I mean, we have organisms on Earth that don't require sunlight that could live 1.6 kilometers underground, should they wish. So that's not so bad. You can do all sorts of wonderful things with electrolysis with these organisms. They can be looking at actually using the salts that are in the water. The one thing we've got to be a bit careful of is that cells, at least cells as we understand them, probably won't survive in this lake.
Is it because of the brininess?
It's very, 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 very briny. So what happens is you get this, and this is one of my new favourite words, after syzygy, of course, is you get osmotic potential.
Ooh, okay. Talk me through that one. Which
basically means, so we have a cell which is like this little globule, and it's got basically water inside of it. Now, if you put that cell into something which is as salty, as briny as this lake, then it's so salty that it starts to extract the water out from the cell. So it basically pulls the water out from inside the cell, and then the whole cell dries up and desiccates and kind of dies.
Which, when you're a microbe, is not a good end point of that reaction.
Because cells are pretty much all you have at that point.
Yeah. So if your surroundings are basically sucking all the juices out of you, not good. Not a good environment.
So if there is life, it's definitely not as we know it, but maybe that's not so weird.
Okay, so the answer, water, Mars, life, ? In this case is maybe not sure that this is going to give us a lot more confidence in that direction, but it's not closing the door entirely either.
It's definitely not the easiest form of life to discover, shall we say.
Mars is not easy anyway, is it? Let's face it.
Mars is like a toxic bomb, isn't it? Everywhere we go on Mars, it just seems to be less and less hospitable to us and to other life forms.
But hey, let's send humans there. Why not?
Why not?
All right, so we've got a liquid lake of briny water underneath the South Pole of Mars. That's great. Sounds good. We're going back to Mars in a few years' time. I mean, we're still there, electronics willing after the big storm. But we're sending even more stuff up. So what's next? Well, I can tell you what we're definitely not sending. Okay. And that's going to be a robot with a 1.6 kilometre long drill. Yeah, I mean, given that the ones up there at the moment are basically going into the top centimetre or so of topsoil, and that's about as far as they can drill, even the next generation, they might get meters? Maybe a metre, yeah. Maybe. So 1.5 Ks is a big ask. Yep, that's not going to happen. No. But in terms of the salty lakes, what we really need to
see is, can we see more of them? Because I think it's a lovely, actually, quotation from the end of the science paper, is that there's no reason to believe that this is the only one.
Right. I mean, given that they discovered it almost by accident in the data that they were collecting, went, hang on, back up a little bit. Let's look at that in more detail. That's just one. Right.
Yeah. So I guess the big thing about these lakes is to find some more. So we'll definitely be looking at that Mars Express data a lot more carefully. And when we have other orbiters going around, which there's another half dozen that we're going to send in the next few years, I'm sure. Then we'll also be looking at some higher resolution pictures and seeing if we can also confirm these lakes.
I mean,
hopefully lakes plural.
In terms of Mars missions, the orbiter's the easy part, really, isn't it? Getting to Mars is not easy. Let's be clear. Well done to anyone who's managed to get anything to Mars, even if it's just crashed. But between orbiting the planet and taking pictures of it in all sorts of different ways, or landing on it and driving around, the orbiting part's the easy part. And so we're going to be doing more of that than the landing and the driving around.
Definitely, yeah. And we can put more instruments on board and they can be less fragile and all that sort of stuff. But ExoMars is definitely one to follow.
So all of these different discoveries that we're having like this just give us more and more impetus to say, we've got to get more instruments up there and start sending back more data so that we can see more and more of this sort of stuff.
Yeah, and even maybe more and more storms. They're exciting too.
Let's hope not too many. Well, that brings us to the end of this particular Mars edition of the Syzygy podcast. Emily, how can people contact us if they want to contact us here on the show?
Well, if you happen to be on Twitter and you saw Syzygy Pod at Syzygy Pod, then you would have seen it light up on Friday night when all the wonderful eclipse things happened as well.
Yes.
So that's definitely a good way to get your news quickly.
It's always a good way to tell whether or not there's anything happening in astronomy and in the night sky is when our Twitter account goes, oh, look, there's stuff happening. So yes, there's Twitter, there's Facebook as well.
Yes, yeah, good old Facebook. Gotta love it. So just go and search for Syzygy, SYZYGY. You'll pick us up there.
Or you can just go to our website, syzygy.fm, and go and find the contact page there and fill out the form. And why would you do all of this? Because you can actually ask us questions. You can send us information. You can make comments. You can just say hi. Any and all of the above. We would love to hear from you out there in listener land. There's something else that you could do as well. If you felt like giving us a little review on your podcast client of choice, whether that's through Apple Podcasts or Google Podcasts or whoever else, give us a review. Let the world know what you think of us. And that's not just for our own egos, although that is good. Don't get me wrong. It's nice to hear from you. The most important part of that is because it helps other people to find us. And our mission here at Syzygy HQ is to spread the good word of astronomy as far as humanly possible. Emily's been doing her bit, right? She's been working really hard doing the world's media. And now we're asking you guys out there in listener land to do your bit. Give us a review and let us know what you think. But that pretty much brings us to the end of the show. Thank you, as ever, to the University of York for allowing us the time and space to do this. Emily is an astronomer here at the University of York, and it's not necessarily written into your contract, but they're not stopping us either.
That's always the best thing.
So that's always a good thing. Otherwise, we'll see you for episode 16, probably in about a week or so.
Yep, and go see Mars.
Go and do it.
Go do it. Go do it now.
It did surprise me, though, that when they got to the story, they then went, so there's an eclipse happening, watch this, and went into sort of a 5-minute long, here's a graphical presentation of what's going on with background music. And I thought, so what are you going to talk to Emily about? Like, this is basically giving the entire story of what's going on here. When it did we're going into the shadow. Okay, tick that one off. And here's why it's going to be red. Okay, tick that one off. What's left? Oh, it's going to be really long.
Yeah.
But you did well. So if you're going to lose an eclipse to weather,
oh my goodness,
cool
those
changes.
thunderstorms were so awesome.
Even if it did shut down most of the country.